All right, guys, welcome to vector operations. Today we're going to talk about them in the rectangular coordinate plane. So really what we're talking about is when vectors are written as linear combinations, how do we add, how do we subtract them, and how do we perform scalar multiplication? So by definition, to add or subtract two vectors that are written in linear combination form, remember that A1 and A2 are scalars. B1 and B2 are scalars, and I and J are the unit vectors, and we talked about that in a previous video. So here's the two definitions we use. So to add the vectors, you simply combine the A scalars, multiply by unit vector I, and then you add the B scalars and multiply that by vector J, unit vector J. Subtraction, same thing. You subtract A1 and A2 scalars times I, but in the middle there it's still plus, and then B1 minus B2 scalars times unit vector J. So these are the definitions that we're going to use to perform vector operations. Okay, so in our first example, if vector V is defined as 5i plus 4j, I'll say it like that because I don't want to keep saying vector this. These are vectors, okay? And W is defined as 6i minus 9j. Find each of the following vectors. Vector V plus W, vector V minus vector W. So again, I write what I'm trying to do. The blue here is the substitution of what I know each vector to be. And now I'll combine, the like terms, the I terms going together. So here's A1 and A2, so 5 plus 6 times unit vector I plus 4 plus negative 9, that quantity times vector J. 5 and 6 plus 6 make 11 times I vector unit vector I minus, now this goes from plus to minus because you have a negative 5 here, so 5 times unit vector J. So there's the sum of the two vectors. To do the difference, you follow really the same pattern. I wrote my vectors here. Here's V minus W. Okay, so it's minus here, but notice when I use the definition, 5 minus 6 in parentheses times unit vector I plus 4 minus negative 9 times unit vector J. 5 minus 6 is negative I, unit vector I, plus 4 plus 9 is 13 times unit vector J. There is the difference. Okay, so there's the definition. Watch that little plus sign, but notice how it's minus inside when I'm subtracting the scalars. The second example deals with scalar multiplication. Okay, and two examples here. So I'm just using 5i plus 4j. All the vectors are not just 5i plus 4j. I use that a lot in this video, but that's okay. I'm going to find each of the following vectors if V is defined as that. So I want 6 times vector V, and B I want negative 3 times vector V. So this is really the distributive property. So 6 times, I substitute my vector V in, 5i plus 4j. And then I'm going to multiply the 6 times the 5 and the 6 times the 4, which I've done here. And so I get 30 times unit vector I plus 24 times unit vector J. Okay, so there's the 6 times unit vector V. Part B, I'm multiplying each term by negative 3. So negative 3 times my unit vector V, and then I distribute the negative 3 times 5 times unit vector I plus negative 3 times 4. So I get negative 15 times unit vector I minus 12 times unit vector J, and there's the product of negative 3 times unit vector V. The last example is a linear combination of two vectors. V is defined as 5i plus 4j. W is, again, 6i minus 9j. So I want 4 times vector V minus 2 times vector W. So there's my problem. Here's the substitution. 4 times there's vector V minus 2 times vector W. Okay, so I distribute. So I get 20i plus 16j if I distribute the 4 to A1 and B1, 2 to 6, and 2 to 9. Notice how I use the negative sign. So negative 2 times this is minus 12i. Negative, negative makes positive there. And so now I can just combine 20 minus 12, there's my I terms, plus 16 plus 18i. So now it's just adding, basically almost adding like terms, okay? Like 20x plus minus 12x, 16y plus 18y. So there's the combination, just adding like terms. So my final difference here is 8i plus 34j. So if you guys have any questions or comments, you can type them below, but that was vector operations on the rectangular plane.